So now that we've gone through why a negative exponent and how a negative exponent can be expressed as a positive in the denominator, we're going to use just our basic integer rules and exponent rules to use and solve as a shortcut. So this first problem, these are the same problems as what we just did, just showing you a shortcut. So I have the same base for problem number 1 of 5. I see that I am multiplying. So thinking back to the other week, when I am multiplying with the same base, I add my exponents. So this is for those of you that are really good with adding and subtracting with negative numbers. So I need to add -2 plus 3, so my base will stay 5. If we need to go off to the side, -2 plus 3. I see that they're different signs, so I'm going to subtract. 3 minus 2 is 1. I have more positives, my +3. So I get 5 to the first power, which is the same thing as 5. And if you look back at the way we did it originally, you'll see that we get the same answer. For the second one, I'm going to do the same thing as I did before, and I'm going to first rewrite it vertically. 4 to the -3rd divided by 4 to the -6th. Now again, I see that I have like bases, so when I'm dividing with like bases with exponents, I'm going to keep my base and I subtract my exponents. So that means I need to do -3 minus -6. So this is where writing it out might help you. And again, only if we really understand our exponents, because we need to remember that when we subtract a negative, this really becomes a positive. So this becomes -3 plus 6. I have different signs, so I'm going to subtract. 6 minus 3 is 3. Since I have more positives, it's going to be a positive, and I get 4 to the 3rd power. And again, if we compare it to the way we already did it, we'll see that we get the same answer. So all we're doing with this is we're using all of our exponent rules that we've already learned, but now these are just harder because we had negatives. The way we did it before, when we rearranged it to make them positives, that was easier because we then all had positive exponents. You can do it this way if you really understand and work well with negatives. Again, these are the same problems as what we just did, but we're going to use our integer rules instead for this shortcut. So for this first one, I see that I have all like bases. I see that, again, my numerator I can simplify. First, I have this power to power, so I'm going to multiply. It's going to become 9 to the 6th times. I'm going to bring down everything else, 9 to the -4th over 9 to the -2nd. I still have my numerator that I can simplify, but again, now instead of moving my negative exponents, I'm just going to use my exponent rules. I am multiplying with like bases, so my base stays the same, and I need to add my exponents. So 6 plus -4. I have different signs, so I'm going to subtract. 6 minus 4 is 2. I have more positives, so this is going to become 9 to the 2nd over 9 to the -2nd on the bottom. Again, I have like bases of 9. I'm dividing, so that means I need to subtract my exponents. So I'm going to do 9 minus -2. 9 minus -2, not 9 minus 2. Again, this is where you have to be very confident with using using negative numbers. Just like we did before, subtracting a negative is the same thing as like a positive, so 2 plus 2 is 4. So our final answer is 9 to the 4th power, and we can check that with what we did in the previous videos. Okay, next one. I see that I have different bases both in the numerator and the denominator. In the numerator, I cannot combine anything because I have two different bases. I have no like bases in the denominator either. So I can't add anything, I'm just going to go ahead and subtract. Since I'm dividing everything, let's look at my like bases of 7s. I have 7 to the 2nd power divided by 7 to the 4th power. So I'm going to keep my base the same as 7. I need to subtract my exponent since I'm dividing. 2 minus 4 is negative 2. Because I have more negatives, I'm taking more away. Times, let's look at my other common bases of 2. 2 to the negative 3rd divided by 2 to the negative 4th, so my base stays the same. Dividing, so I subtract negative 3 minus negative 4. Again, when I subtract a negative, it becomes a positive. So this is really negative 3, plus 4. Different signs, so I subtract. I have more positives, so it's 2 to the 1st power. Now, this is where you still have to understand how to turn this negative exponent into a positive. I can't simplify anymore, but this is technically not the best way to express my final answer. My 2 to the 1st power is just 2. It's going to stay there. But remember, if I have a negative exponent, I can turn it into a positive by putting it in the denominator. So my final simplified answer is 2 divided by 7 to the 2nd power. So we use the shortcut by our exponent rules, just subtracting with our negatives, but we still have to understand that if we have a negative as our answer with our exponent, I have to move it into that denominator to make it a positive exponent. Okay, just like before, I have 2 different bases. However, this time I see that in my numerator, I have like bases, so I can go ahead and simplify. 3 to the negative 2 is going to stay there, times. If I am multiplying, again, I'm going to add my exponents. So negative 8 plus 5, different signs, so I subtract. I get 3, but this time I have more negatives, so it's going to be a negative 3. So times 7 to the negative 3rd. I can't combine anything at the bottom, so I'm just going to rewrite it. Now, since I'm dividing everything with like bases, I can go ahead and subtract. Remember, this 3 really has an invisible 1. So I get 3 to the, and again, if I'm dividing, I subtract negative 2 minus 1. This is going to give me a negative 3. So you got to know your negatives. If I'm at negative 2 and I take more away, I'm at negative 3. So this is negative 3 to the negative 3rd power. And then for my 7s, my exponent is negative 3 minus negative 2. Again, subtracting a negative turns into a positive, so this is negative 3 plus 2. Different signs, so I subtract and I get negative 1. Again, we are not done. I do not want negative exponents. Since these are both negative, I have to move both down to the denominator of a fraction. My 1, I will just have a 1 up top. So I get 1 over 3 to the 3rd power times 7 to the 1st power, which is just 7. And again, look back at your notes and you'll see we got the exact same answer. So again, you only use these shortcuts in this way of solving if you truly understand and are good with adding and subtracting negative numbers.